We haven't had a design focus video for a while. Today I walk you through the process in Autodesk Fusion to create this handy door prop that keeps the enclosure door of the Sovol SVO8 from swinging shut. I want to empower you to design quick, functional parts like this for everyday use, making your 3D printer an even more powerful tool in your home. Hey, it's Gergo here. Welcome back to Gergo Print 3D. If you're new, this channel is all about my 3D printing and laser working adventures. And like always, this episode comes with curated, translation-ready subtitles, so feel free to turn those on if you need them. In last week's video, I complimented the Chiditech Q1 Pro for its door having enough friction to stay open during prints that need regular part cooling. You remember? On the plus side, I do like how the front door has enough friction to stay open, something I'm still struggling with on my SVO8. Some clever upgrade will need to be devised there. Well, it didn't take long. Yesterday, I set out to fix the issue, and it turned out to be so easy and elegant that I knew it was something all of you should try. Autodesk Fusion, which I like to use, is still free for personal use, so you'll be able to follow along. Just be sure to download the limited free version and not the free trial, which would expire after 30 days. Now, the glass doors on the SVO8 are beautiful, but the hinges are so frictionless that it's hard to keep them open. Even though my desk isn't slanted, I noticed the left door would close by itself as the printer vibrated during prints. So, in a nutshell, here's what you can expect in the next 12 minutes. We'll kick things off with a hand-drawn sketch and some essential measurements. Then we'll dive into creating a 2D drawing. Next up, we'll take that drawing and extrude it into 3D space. After that, we'll add fillets for better printability, strength, and aesthetics. Then it's time to slice, print, and hope for the best. But as you might guess, not everything goes according to plan. Can we get it perfect on the first attempt? The good news? Stick around to see. As I analyzed the situation, my first idea was to create a part that straddles the upper edge of the door, with two wings pressing against the upper frame of the printer. I used a handy digital angle finder to measure the angle of the fully open door, and my favorite digital caliper for some basic measurements. These are essential tools for functional designs like this. In case you don't have these instruments, I'll link to some really inexpensive alternatives on AliExpress in the description below. After quickly jotting down the values in a simple sketch, I jumped into Fusion to draw the first version. We begin by creating a 2D sketch on the horizontal plane. We'll start with a simple rectangle for the back, measuring 83 millimeters wide and 4 millimeters deep. Don't forget, you can use the tab key to toggle between dimensions when inputting these values. Now, last time in Fusion, I showed you how to use named parameters. This time, we'll go ahead and input the measurements directly into the drawing, but keep in mind we'll still be using constraints and cross-referencing related dimensions to make future tweaks a breeze. Speaking of tweaks, let me just tell you up front, this design will need a second revision after printing the first prototype. So if you're following along, watch through the whole process first, since some of the measurements will change in the final part. Let's move to the glass section. We'll draw one side of the glass, measured at 110 degrees from the side of the printer, making it 40 millimeters long. Then we'll draw a parallel line for the other side of the glass. Don't worry about its length just yet. Fusion does a good job helping with alignment, but we'll use the parallel constraint tool to ensure these lines are perfectly parallel. Just click on the parallel tool, then on the second line, and select the first line to lock it in. Now, to make the lines equal length, we'll add a perpendicular line to connect them, ensuring it meets the endpoint of both lines. We'll also set the glass width using the dimension tool, 3 millimeters wide with a 0.2 millimeter clearance for the printed part to fit on it. Let's position the glass relative to the wings. Set the distance between the base of the glass and the right side of the first rectangle to 40 millimeters, minus half the clearance. For the next step, we'll add 2 more parallel lines on either side, both reaching the perpendicular line we drew earlier. These will form the printed walls that hold the glass. The depth for these should match the depth of our first rectangle. Instead of typing the value, we can click on the existing dimension to cross-reference. That way, if we change the depth later, it updates everywhere. See? And we are nearly there. Next, we'll tidy things up by coinciding the endpoints of the lines to clear up the design. Finally, we'll add room for the hinge by drawing another perpendicular line across the 4 walls, setting its distance from the glass base at 12 millimeters, as we measured. Now the fun part. Let's extrude this into 3D space. Finish the sketch, select the extrude tool, and extrude all selected areas to 10 millimeters. It's starting to take shape, right? But we are not done extruding yet. The sketch gets hidden when we extrude, so we'll make it visible again. Select the 2 walls for the glass and extrude those by 25 millimeters or negative 25 millimeters, since we want them to go in the opposite direction. Now we can hide the sketch. Look at that, it's coming together. This would already function as a part, except for one little problem we've now uncovered. There's nothing keeping this piece from sliding away from the printer at the base of the door. After closely inspecting the door mechanism, I realized there is a 1.5 millimeter gap between the printer and the edge of the open door, about 8 millimeters deep. We'll need to design a small hook to hold it in place. Back to the sketch. We'll add a small rectangle aligned with the base of the walls, making it 1.2 millimeters thick to leave room for clearance. Use the coincidence constraint to ensure the ends align perfectly with the walls. Then, of course, we extrude this little hook by, let's say, 7 millimeters. Nice. So, can we print this? Yes, but it wouldn't be very strong. Perpendicular edges along layer lines tend to break easily. This is where the fillet tool works its magic. Fillets round the corners, strengthening the part while making it easier to print and aesthetically pleasing. I tend to add these by feel. Watch how I can select multiple edges at once to round them uniformly. You can apply fillets step by step or group several edges into one fillet operation in the design history. And it's all set. Let's rename this body SVO8 door prop to make saving versions of the mesh easier later. Right-click and select Save as Mesh. The file name for the STL is automatically generated for us. Next, we can pull the file into Orca Slicer and flip it on its top for supportless printing. For a part like this, my go-to is the default PLA preset. After sending it to the printer, I get a perfect first layer, and I have to say, I'm really pleased with the print quality of the SVO8. With preprint preparations, this part takes less than 20 minutes to finish. While we watch the print, a quick note on printer efficiency. If I had been using my T300 for this short print, it would have been even quicker. Thanks to its stored temperature-dependent bed meshes, coupled Z motors, and an AC heated bed. The preprint overhead on the T300 is less than a minute compared to the SVO8's 5-minute overhead. Either way, the result looks great. It fits the door nicely and does exactly what we designed it to do. That said, I noticed we could make it look even cleaner if we shortened the left wing by 7.5 millimeters. And I also made a slight measuring error on the hinge. It turns out we can bring it 7 millimeters closer to the side of the printer. But here's where Fusion's parametric design really shines, because we set up our constraints properly, updating the design is going to be a breeze. Before I show it, however, I'd like to ask for a tiny favor. If you're finding this video helpful or interesting so far, please take a moment now to hit the like button and subscribe for more practical 3D printing tips and design walkthroughs. So back to Fusion, we double click the sketch, trim 7.5 off the width of the left wing, and reduce the hinge spacing from 12 to 5 millimeters. And this is the magic. The 3D model updates instantly when we exit the sketch, though the fillet on the left side needs a quick tweak. No worries though, just follow your instincts and round a different edge this time. That's the beauty of working with parametric designs. We have so much flexibility. And now that we are closing in on the final version, it's time for a little bit of customization. I create a new sketch on the top surface of the part and add a text box to carve in my name. I'm using the font Impact, size 5, centered perfectly. Using the extrude tool, I select the text and set the distance to minus 0.45 millimeters, which will engrave the text 2 layers deep. Perfect since we are printing it upside down on the bed. Saving the updated design is just as easy. I right-click on the body again and select Save as Mesh, and it automatically overwrites the previous STL. So over in the slicer, we can right-click on the model and just reload it, which keeps the orientation and print settings intact. I could have bumped up the number of walls or increased the infill density, but honestly, the first prototype felt sturdy enough with 2 walls and 10% infill, so I stuck with those settings. Another 15-20 minutes later, we've got the perfect piece this time. It slides right into place and keeps the door propped open just like it should. And here's a bonus tip. If you need one for the right side, simply mirror the print. Just one thing to keep in mind, if you print it in black like I did, it blends into the printer so well that I've actually forgotten it was there a few times when trying to close the door. A more visible color might be handy. I've made the models available on Call3D for $1 or $2, but since you followed along, you now know how to make one yourself for free. Even more exciting than this little project is the endless possibilities. With a CAD program like Autodesk Fusion and our 3D printer, there's almost no limit to what we can create. Videos like these are made possible by the kind supporters on Ko-fi.com and all of you who use my affiliate links to get your 3D printing devices and supplies. A heartfelt thank you for your continued support. It means the world. And a big thank you to those of you who even watch my videos sponsored by laser companies. I do my best to keep 3D printing and laser cutting videos in balance. If you enjoyed this Fusion 360 tutorial, I made a similar one back in February, which you can check out here. Or if you're curious about the Sovol SVO8 and my experience with it, take a deep dive into my full playlist here. And as always, make sure to go print 3D. Thanks for being awesome and watching yet another Gergo Print 3D video all the way to the end.